No, it's free. Actually, no, I did pay for it. I think it's like $1 or $2. Okay, let's get started. So week 22. Okay, so chemistry test review. Actually, I'm gonna do this.
Wait, Mr. Wong?
Yes.
Do you have extra paper?
No, I don't. Okay.
Come on.
Okay, let's get started. Okay, so first you need to know molar mass, right? Molar mass is okay.
I'm supposed to be on Facebook.
Enough.
He's on Facebook.
Remember, I'm recording.
You recording?
Yes. I had to restart it now.
I'm sorry, I didn't know that.
Okay, so molar mass is mass per mole, right? It's telling you how much mass I have in 1 mole of substances. So the unit is gram per mole. Okay. So for example, let's say I wanted to look for the molar mass of magnesium sulfate. So magnesium sulfate is MgSO4. How do I look for molar mass of magnesium sulfate? Very easy, right? You just look at the periodic table and tell me what is the molar mass of magnesium, what is the molar mass of sulfate, and what is the molar mass of oxygen. So molar mass of magnesium is 24. Molar mass of sulfur is, where's S? Okay, 32. Molar mass of oxygen is 6, which is 16. Right, so we round it to the whole number. So add them up together, 24 plus 32 plus 16 times 4. 4 plus 32 plus 16 times 4. It will be 120. So the molar mass of magnesium sulfate is 120 gram per mole. This is saying that 1 mole of magnesium sulfate has 120 grams of magnesium sulfate. This is what it's trying to tell you. Okay, with this you can make ratios, right? If you know that 1 mole has 120 grams, let's say the question tells you that if I have 5 mole of MgSO4, how many grams of MgSO4 do I have? 5 times 120, right? You just do 5 times 120. So this will just be 5 times 120, which is 600 grams. So this is a ratio, it's a very powerful ratio that you can use to figure out grams or mole. Okay? So remember, molar mass is mass over mole. If you're given mole, you set mass as X. If you're given mass, you set X as mole. Okay, so far so good?
Yeah.
Okay, next, you need to know what is number of moles, right? 1 mole is equals to, yeah, 6.02 times 10 to the times 10 to the power of 23, not negative 23. I did not. I said negative accidentally. Okay. So 10 to the 23, right? So 6.02 times 10 to the 23, number of particles. Right? It's basically saying stuff, right? Number of particles, molecules, ions, so on and so forth. Depends on the context. Like for instance, let's say I have 1 mole of potassium. So how many particles of potassium do I have? It's just 6.02 times 10 to the 23 potassium, right? Remember, mole is just like your dozens, right? A pair, a dozens. It's saying how many, right? It's a combo, like a package, right? So 1 mole is representing 6 times 10 to the 23. So with this, it's also a ratio. So let's say I have 10 mole of potassium. how many potassium do I have? If I 10 more potassium, how many potassium do I have? Yeah, you just multiply by 10, right? Everybody's good with ratio, so you know that if I have 10, I must have multiplied that number by 10.
Yeah.
Okay, so let's say the question is asking, let's say I have 3 times 10 to the 23 potassium. How many moles of potassium do I have? 0.5, right? You divide that by 6.02. It's just half of mole. Okay, so with that, it's kind of easy to look at it, but you need to know how to do the math. Okay, so I have a table for you, right? During the test, I'll give you the equation. Okay, I will give you the equation. But this is also a very useful chart for you to know. Yes.
How do you get 0.5?
Because you know that 1 mole is 6.02, right? So you just write like this: 1 mole over 6.02 times 10 to the 23, right? Is equals to, I don't know the number of moles, I put it as x. How many moles is given? 3 times 10 to the 23. So you set it out as a ratio, do cross multiplication, and then x will just be 3 times 10 to the 23 divided by, 6.23. I kind of simplified 6.02 to 6. So you can see that this math is just 0.5. Because you can see that it's half of the original, right? 3 is half of 6. So the number of mole must be half as well. Okay. So this is a very useful chart for you to remember. You always put number of moles in the middle. Number of moles. If you want to go from number of moles to mass, you multiply number of moles by molar mass. If you are given mass, you want to look for number of moles, you divide it by molar mass. Okay? So if you wanted to look for number of particles, you multiply by Avogadro's number, which is 6.02 times 10 to the 20, times 10 to the 23. But if you want to find number of moles, you divide it by Avogadro's number. Okay? So put it like this, it will be simpler. Okay? So if you remember that chart, it will be very easy for you, right? Number of moles is number of moles times molar mass gives you mass. Mass divided by molar mass gives you number of moles. Okay, so during the test, I'll give you these two formula. Molar mass is equal to mass over mass per mole, right? And then number of particles is equals to, number of particles is number of moles times Avogadro number. So during the test, I'll give you these two equations.
Which two?
Up there. Right? Molar mass is mass over mole, and then number of particles is number of moles times Avogadro's number. Okay? So with this, you need to know the mole ratio, right? Because using mole ratio, you'll be able to calculate it. Okay, so let's say the question is, let's look at one of the quiz questions and see if I can give you an example. Okay, let's say that the question's like this, right? 2 moles of C2H2 react with 5 moles of O2 is going to give you 4 moles of CO2 and 2 moles of H2O. Remember, the number in front of the chemicals is your coefficient. It's telling you how many moles of the substances is going to react. Okay, so the mole ratio of C2H2 to O2 is 2 to 5. So mole ratio of C2H2 to O2 is 2 to 5. So 2 over 5. Okay. So let's say the question is asking, right, based on this equation, what number of molecules of CO2 will be produced if 3 times 10 to the power of 24 molecules of O2 is reacted, right? Okay, so remember how I teach you, right? First, you box out the chemicals that are of your focus, right? You wanted to look at these two chemicals. You wanted to focus on CO2 and O2. So CO2 is here, O2 is here. So the first thing you do is you write the mole ratio. You write the mole ratio of CO2 and O2. So CO2 is 4. So you write 4 over here, and then O2 is 5. So the ratio is 4 over 5. Next, you look at the given information, right? The given information is 3 times 10 to the 24 molecules. Is it in mole? Yes or no? No, it's not in mole. So you have to change it to mole.
Yeah.
So change it to mole.
You multiply it through Avogadro's number, right?
Nope.
Oh wait, no.
Remember, whenever you're looking for mole, it's always division.
Yeah, division.
If you're unsure whether you're doing multiplication or division, look at the formula. Plug and set the variable as x and solve for it. So we know that to find the number of moles is number of particles divided by Avogadro's number. So this would just be 3 times 10 to the 24 divided by 6 times 10 to the 23. Which means this is 3 times 10 to the 3 times 10 to the 24 divided by 6 times 10 to the 23, which is 5. So this is telling you that this is 5 mole. So you know that this is 5 mole, so you set the remaining as x, right? Variable x. So what's going to happen? So you solve for the x, right? What would that x be? You cross multiply, and the x is 5x equals to 20, so x is 4, right? It's already 5 at the bottom, so the numerator must be 4. So x is 4. So this x is 4 mole of CO2. What is the question asking? Number of molecules, right? You know that you have 4 moles of carbon dioxide. Carbon dioxide. What is the number of molecules then? How do you find number of molecules given number of moles?
Multiply.
Just multiply, right?
Yeah.
The formula is given. Yes, question?
I don't get how you get 10 to the 24.
10 to the 24. There's no 10 to the 24.
When you did 3 times 10 to the 24, it's
yeah,
given.
this is given.
Oh, it's given?
This is given. Okay, let me highlight those that are given, right? So all these are given.
And to find moles is division, and to find molecules is
Yes,
multiplication.
so these are given. So you already know that you have 4 moles of carbon dioxide, and I need to answer the question, right? The question is asking how many number of molecules of CO2 do you have? And I know that I have 4 moles. So it would just be 4 times Avogadro's number, which is 4 times 6, which is 24. So the answer is 4 times 6 times 10 to the 23. So molecules of carbon dioxide is 24 times 10 to the 23. Okay, clear? You can also set out as the long equations where you multiply everything at the numerator and denominator, that's fine. But you need to make sure that you multiply the correct thing. Right? If the question is asking for number of molecules, you have to multiply by Avogadro's number. If the question is asking for mass, you have to multiply by molar mass. If the question is only asking for moles, you don't multiply anything. So I saw a few mistakes made in the quiz that's like that. The question is only asking for moles, but you find the mass. You multiply one more column.
What number is it for?
Okay.
Wait, what number is it for?
This is for study guide question 2 for week 22.
Oh,
Okay. So in a given equation, know how to find any of this property, right? The properties can be moles, mass, or number of particles.